Hi guys, I hope you're doing well. I got asked a question for chapter 12b for our vectors unit. The exercises start here, and the question that was being asked was for 5a. We have the vector magnitude of A is 10, the vector magnitude of B is 12, and they want you to find the angle between A and B if for the first one, the summation of the other magnitude is supposed to be 17. So over here, let's just quickly check what the answer is supposed to be for 5a. And then we have here 79 degrees. So the first thing that we would suggest is obviously to draw a picture of the information that's given to us. Let me just set up the board. I did like a partial solution already. So I have here written the magnitudes, and then to draw the picture, just because the larger value is, the summation of the two vectors is larger than those two, then I know I'm going to be drawing some sort of like obtuse triangle. So I automatically just draw this one for vector A for the magnitude here. This one for vector B, I'm moving it a little bit out so that when I draw the vector that's adding them together, it's going to be larger in terms of the magnitude. So the theta that you would try to find first is this one over here. When they ask for the angle between A and B, I don't know if anybody caught it in the lesson, it always has to be tail to tail. So right now, this one is tail to tip, but it has to actually be drawn like this. So the angle between these two, anytime that they ask for it, it has to be drawn tail to tip, tail to tip. So this is the angle that we're gonna find at the end of the day. So because of this triangle here, we're putting it into cosine law. So you have the corresponding side length for the angle that we're trying to find. We do this algebra, and then we get this cosine theta is equal to this negative 0.1875. You always want to round to 4 decimal places when you're doing trig, just because for your calculator, it's going to change significantly if you don't have those 4 values. So I know in terms of the quadrants, if it's negative, it has to be in the second and the third quadrant. And then when I actually get that, I get this angle of, sorry, there's no cosine here, of theta that's equal to 100.8 degrees. So that makes sense, it's in the second quadrant. So if this is the value of theta there, when I try to find this angle here, this one over here, you can say is, I guess, alpha. So this alpha angle here would be equal to 180 degrees minus this 100.8 that we found. And when we get that, our theta, our alpha is now going to be equal to 79. They round it up, so we'll do the same thing, 79.2 degrees. Okay. So that's the trick. Anytime that they ask you an angle between two vectors, it always has to be drawn tail to tail, not this one, which is tail to tip, tail to tip.